Good morning, everybody. This is Ian Trevethan. I am the Education and Outreach Manager here at the Sternberg Museum of Natural History. And this morning I am in one of my favorite places in the museum. I am hanging out in paleontology collections. And I don't get to spend as much time in here as I would like because I chose a career in public education, and my background was always in vertebrate paleontology. So when I do get a chance to come down here and just sort of hang out, I really enjoy it. So today I thought it would be fun to kind of investigate some of the nooks and crannies of our paleontology collections area and explore some less common fossils in our collection. And what I mean is I am in search of dinosaurs today because dinosaurs are something that everybody likes to hear about, it seems, even though we specialize primarily in marine environment fossils, and we also have a lot of ice age type mammal fossils as well, and turtles and that kinds of things. So it's not very common to find dinosaur material in this area of Kansas, and it's not often that we find material in Kansas proper. It does happen occasionally. There are some dinosaur bearing rock formations that we have recovered dinosaur fossils from, but a lot of the things I'm going to show you actually don't originate here in Kansas. They actually come from places like Colorado, the Dakotas, Montana, Utah, those areas where there is more terrestrial environmental rock, or I guess rock that represents a terrestrial environment, which means basically where land animals were living. So you got to have the right age rock, and you've got to have the right habitat for whatever animals you're looking for. So let's explore, and I will show you some of the things that I like to sort of hang out with when I get a chance. So let me flip the camera here. And we're sort of reorganizing. We're actually just getting ready to paint our floor in here, so I have to excuse our sort of things around. But this is an example of some big dinosaur bones here. This is, I believe this is a Tyrannosaur leg bone. I think it's a tibia. And it's just for scale. This is my hand here. So this is the end of the bone here. And it just gives you an idea of the size and girth of, this is just a single bone. So this would be the lower part of the leg. It would be one of the bones that's in the lower part of the leg. So this would actually pair up with a fibula. So you can actually use your own skeleton as a reference. You have a tibia and a fibula on your lower leg, and this would be what a T-Rex tibia would look like. So this particular specimen is from South Dakota. So this would represent a late Cretaceous dinosaur, Tyrannosaurus rex, which is actually a fairly common dinosaur in Cretaceous aged rock. So that's kind of cool. This is another dinosaur bone, but I am not sure what kind of dinosaur this comes from. I don't have the data on that. But just again, a good indication of size. And then we have up here, this is a centrum of a sauropod vertebra. So what a vertebra is a backbone. This is part of the spine. And the centrum is the middle part of that vertebra. So that's what we're looking at. This is a sauropod. So this is a long-necked dinosaur. And this is caudal vertebra, which means this is part of a tailbone. So if you imagine the long-necked dinosaurs that roamed primarily during the Jurassic, but there were some in the Cretaceous as well, this would be part of the tail. And it's been pretty beat up. It's missing, you know, some of the spines and stuff. But this is the central part of that backbone. And again, there's my hand for size. So it just gives you an idea. This is the tailbone. So this is probably a little bit further down towards the tip of the tail. And again, just for size reference, as I go up and over here, what we're looking at here is this is actually part of a collarbone. This is, oh, I lied. This is an ilium. This is part of a hip bone, is what this is. So again, this is a sauropod dinosaur. So this would be sort of down where its hips are, just to give you an idea of size and girth. So again, I'm not going to try to pull these out of their drawers here, because these things are almost as big as I am and probably outweigh me by several hundred pounds. So again, just some fun material that we don't often see in Kansas. So that was examples of some of the big stuff. So let's see, where did the sauropod come from? My guess is, well, it doesn't say where it came from. My guess is it would come from Colorado, but it doesn't give me a location of where it came from. My guess is this is a Jurassic Age animal, so approximately 150 million years old. And you would find that more west of here. So in parts of Colorado and Utah is where often you would find that age of dinosaur material. And then we've got a lot of fun casts here. And these are casts of a dinosaur called Comptosaurus, which is a Cretaceous age dinosaur. And the reason we have casts, this is primarily for teaching, and the reason we use casts for teaching is because if I were to bring an actual fossil bone out of the collection and something were to happen to it, well, gosh, that would be terrible. I mean, not only would I be in big trouble with our curator, but we would lose very valuable information. So it is not very common practice for an educator like myself to take actual fossils out of our collection, but rather we make exact copies of the fossils that are in our collection. And that way, if something happens, if it gets dropped, if it gets bumped or scratched, it doesn't damage the actual fossil itself. So it's not that hard to fix or replace if something should happen to it. And trust me, traveling around even a state like Kansas, but I would imagine some of the bigger museums even do, you know, the entire country and sometimes internationally, things happen, things get broken. So packing things around and traveling with them is hard business. So always good practice to have casts of the actual fossil. So these are more Comptosaurus casts. And what you're seeing here is actually these are half casts. So these are leg bones is what we're looking at. And again, just my hand for scale here, just to give you an idea of how big these things are. And I apologize, I am my own camera person today, so if the camera work is a little bit shaky, that's why. What we're looking at here are Allosaurus jaws. So Allosaurus was a Jurassic age carnivore and very, very common in Utah. And here is the rest of the skull that those jaws belong to. So just an idea of sort of what this critter would have looked like.
And now for the rest of the story.
For the rest of the story. Hey, look, I'm not alone anymore. Reese came in.
How are we doing, Ian?
Good. I'm just hanging out in paleontology collections. I was just telling our viewers I don't get as much of a chance to hang around in here as I sometimes like, because I'm out doing education stuff rather than paleontology stuff, which is what I was trained for. And I do miss it sometimes, so it's just nice to be in here and talk about stuff with our viewers. So I was just showing them the different kinds of dinosaur stuff from kind of generally around, not necessarily from Kansas, because as we've discussed earlier in some of our other talks, there are not a lot of dinosaurs that are commonly found in Kansas. We're much more of a marine environment unless you do a time jump to, say, the Ice Age, in which case we were more of a, what would you call it, a riparian forest or something.
Well, we were a grassland in the Pleistocene, right?
Well, we were an evolving grassland.
We were an evolving grassland. Yep.
During and just after the Ice Age. So anyways, I just thought it'd be fun to talk about dinosaurs. So this is a fun animal. This is an Archaeopteryx. This is a cast of a very famous fossil. And there has been a lot of discussion as whether this represents the first bird or one of the earliest birds, or whether this is a dinosaur. And got into a very interesting discussion about this animal when I was a student, and I was taking an ornithology class, and the professor, Dr. Farley, asked, "Is this a bird or is this a dinosaur?" And I jumped up and said, "Yes!" And he was impressed with my enthusiasm. Mm-hmm. But it's different than a modern bird. As you see, it's got 4 limbs. So this would have been sort of a 4-winged glider rather than an active flapper. So a little bit different than some of the modern birds we see. But, nature is interesting. There were a couple of different bird-like experiments through time. Mm-hmm. And this was one of the earlier ones. And, so we know that the bird lineage was doing interesting things, and some things worked, some things were selected for, and some things weren't. So
it's a fascinating story when you think about it. At the time, the idea was if it has feathers, it is a bird, right? Mm-hmm. And even though there's skeletons of a little dinosaur called Compsognathus, which basically looks like Archaeopteryx, except for not having feathers. It was thought that here we've got our first bird, and it is a bird, and it's not a dinosaur. And there was many arguments about whether birds were dinosaurs back in the 80s and 90s. And when I went to North Carolina State and I was studying warm-blooded dinosaurs, there was a guy at the University of North Carolina named Alan Fiducia who was, "No, birds are not dinosaurs. Birds are their own special creation. They're completely independent of dinosaurs, and I can tell you that because of feathers. You will never find a feather on a dinosaur. Dinosaurs are cold-blooded things. They didn't have feathers. Birds have feathers. They're warm-blooded. They're completely different."
Oops.
And we had a number of discussions, and it wasn't much more than 5-6 years after that, we started finding lots of feathered birds in China, but also feathered dinosaurs. And now we have so many feathered dinosaurs that are dinosaurs. We have tyrannosaurs that have feathers. We have all sorts of dinosaurs that are not even the actual avian lineage dinosaurs that have feathers.
Yeah.
So feathers are not a unique thing.
Well,
to
and
birds.
there are some things I can see in the skeleton, that are hard to compare to a modern. Modern birds, the flying, active, flapping birds, they have a keeled sternum, and I'm not seeing that here. I'm not seeing a lot of big ridges from muscle connections here for active flapping of wings here. However, I would hypothesize that this would probably be a pretty effective glider. So, I always imagined, the big argument was it from the trees down or from the ground up? And then later on, assisted incline running.
Yes, that's the big one.
Is the big one, that this animal is running after a prey item, for example. And that prey item scurries up a tree, and so does the bird-like dinosaur. And then from there, it can sort of glide off of that tree and land back on the ground. Somewhat like I don't know, what's a good analogy? Maybe a flying squirrel almost.
Yeah, and there's lots of evidence of birds today that when they're going up a tree, they flap their wings to hold themselves to the tree so that they can run up the tree.
Yeah, there was, I wish I could remember his name. There was a guy at the University of Montana
That's right. Yeah.
that did a study, and I can't remember what birds they were. Very chicken-like birds.
Yeah.
Like I wish I could remember what kind of bird. But he would actually take video of them running up an incline, going steeper and steeper and
steeper incline,
and watching what they do with their wings or their arms and limbs, whatever you want to scientifically call them. And you know, we gained a lot of insight just by watching that slowed down film.
Yeah. So the Archaeopteryx and some of these early feathered dinosaurs or early birds, were very likely flapping very hard, but using that to help run up the trees. And they were not going to be, as Ian said, they're not long distance powered flyers, but they could glide out of the trees. But doing all of the flapping to even run up the tree is going to start building muscles so that they could eventually get better and better at powered flight. But they were not going to be really good until you got a big sternum so that you have really large flight muscles. But they were working on them. And so, yeah, feathers could be for display, for sexual dimorphism, which we talked about yesterday.
Yes, we did.
But also, they ended up then being used very likely to help them get up into the trees, because you could chase food, or these guys are pretty small, and there were lots of smallish to medium-sized dinosaurs that would be happy to munch on them. So the best way to escape or get away would be to run up a tree and get high enough that you're not going to be eaten by
that your predator is not going to chase you. And it's an interesting discussion about what feathers were originally doing for these animals. So in my mind, I always imagined, that there was, maybe it was insulation to keep these critters warm, and then eventually they started using them as displays for either competition or to attract a mate. And then, it could be that, this sort of process of, evading or chasing prey or evading predators could have resulted in sort of this assisted inclined running sort of thing. And then they discovered, that this was useful for gliding, so a really fun discussion to think about.
It's because flight feathers are very, very different from downy feathers that you can use for insulation. So that takes a process. I also learned that there are some really cool studies on scales and feathers.
I was just about to say, structural color versus what do you call that? Structural versus pigment, I guess is what I'm trying to say.
There's lots of cool things with color, but even before that, there's what I found fascinating is when people looked at the sort of the ontogeny of scales, at how scales develop, that cellularly, the cells that become scales go through a phase of being a feather first, and then they get past that in order to turn into a scale. So actually,
so it's made of the same material, right? It's keratinous material.
Yes, made of the same sort of material, but actually a feather developmentally in an embryo, the potential for developing a feather comes first, and it has developed past that in order to become a scale.
So does that mean it's a primitive state?
So it is kind of almost a primitive state, which is really weird because almost everything had scales. And so it was almost like you had to stop the timing of the development a little bit in order to have a feather show up instead of a scale.
I would consider feather structures to be derived, or sort of, what's a good word for derived for those of us who don't speak dork? Evolved, or sort of a novel thing. But really, what Reese is talking about is the feather-like structure is an early.
It's early in the developmental embryonic stage.
Right. So does embryonic stage necessarily equate to evolutionary stage? Is the question. Now we're going to go deep.
Oh, you're going to ontogeny.
We just lost like
phylogeny recapitulating ontogeny.
Okay. So one other thing I want to look at before we go is we have a hadrosaur tail here that is really fun. You want to see if you can find it? It's in one of these cabinets here.
We've restructured everything, so it's all
Well,
more organized, but it's not organized the way that I remember.
As some of our regular viewers may have figured out by now, I don't plan things very well ahead of time. So really what I should have done is had the cabinets open before I started filming, but I didn't decide to come in here until about 3 minutes before it was time to start filming because, well, that's how I roll. Usually I'm a little more organized than this, but we're living in strange times. So we have a hadrosaur tail in here somewhere that is very unusual because, well, hadrosaurs are not a known commodity in the Western Interior Seaway. But one of the cool giveaways of how that animal got there is there's actually evidence of shark's teeth or shark bites in the tail. But we've got to find it first. And we may not. It may just be, you might just have to take my word for it. This is why proper prior planning matters, as my dad would say. We got a lot of Niobrarasaurus. Here's that's a Camarasaurus, Ornithoschia. And there's a Hypsilophodontid in here. See if it's in here, maybe. There it is, I think. That's not it. That's something else. But just to give you an idea of what dinosaur material looks like, there it is. So they've really done a wonderful job reorganizing our collection. And prior to us having a well-manned and well-organized collection, those of us who've been in this museum for a while have gotten used to finding our fossil specimens wherever they were originally. And now that things are organized, it's a little harder for us to find stuff. Hi! Anyways, I think we're going to call it a morning. Good morning.
It is a morning.
It is. Is it still morning? I don't even know.
It
What
is.
What morning is it? Is it a Wednesday? I think it's a Wednesday. All right. So we're going to say sayonara for today. There will be no afternoon live feed, I don't think, because I've got to do a bunch of stuff for some of the local elementary schools, and I got to get that done before this afternoon. So I will be working on that, and a couple of announcements. Well, one announcement is the museum, tentatively, will be reopening on the 20th of May. Is that
Next
correct?
Wednesday.
Next Wednesday. So we will be slowly opening to the public. We will not be doing a lot of public programming, but we will be having visitors come to the museum. So
we look forward to that.
yeah, we'll have, our hours will be a little bit different than normal. I think we're going to have a little bit more abbreviated hours.
We're going to be open 10 to 4.
10 to 4. So for those of you who are local and at home, come and visit us. We'll be open. So as always, please like and share our live feeds. And if you've got any questions for us, definitely throw those in the comment section and we will do our best to answer them. So we'll see you tomorrow. I believe Alicia will be doing some animals hopefully tomorrow. Tomorrow's Thursday, isn't it?
Tomorrow's Thursday.
Okay, so we will see you tomorrow morning where we'll have some of our animals and our Alicia. And until then...
It's also an animal.
Well, technically we're all animals.
We're all animals.
You're an animal. All right, we'll have a good morning. We'll see you soon.